Here's a great problem, example 4, just a really nice simple application of the quotient rule. It says find the derivative of y equals 5x minus 2 all over x squared plus 1. If you look in the previous section, we actually had a quotient that we found the derivative of, but it was just x in the denominator. It was just a single term in the denominator. And when you have a single term in the denominator, so if it was just x squared on this problem, not the plus 1, just the x squared, you could separate it, simplify, and then find the derivative of each term. But anytime you have a sum or difference in the denominator, for instance, here we have x squared plus 1, separating and simplifying does not work. So here we would have to use the quotient rule. Okay, again, I have the low function and I have the high function. So let's look at it. What's the low function? The low function in this case is x squared plus 1. So what's the derivative of the low function? Well, the derivative of x squared would be 2x to the 1, or just 2x, and the derivative of 1 is 0. So the derivative of x squared plus 1 is simply 2x. The high function in this case was 5x minus 2. What's the derivative of the high function? Well, the derivative of 5x is 5 times 1, which is just 5, and the derivative of minus 2 is 0, so it's just a 5. So what are we going to do here? We're going to do low d high minus high d low over what's below squared. Again, y prime is going to be low d high minus high d low over what's below squared. So let's go ahead and plug that in. The low function is x squared plus 1. Derivative of the high function is 5. Minus, we've got to be really careful here, the high function is 5x minus 2 times the derivative of the low function, which is 2x. I'm going to go ahead and add some parentheses here to make sure you know we've got to distribute the negative. Never forget this is all over the low function squared, which in this case is x squared plus 1, quantity squared. Never, ever, ever FOIL out the denominator in this case. It's not going to benefit you. Always leave it in factored form, because that's going to be our next step, is to simplify, which involves factoring. So never distribute out the denominator. Let's go ahead and distribute out the numerator though. I'm going to do 5 times x squared and 5 times 1. I end up with y prime equals, well, 5 times x squared is 5x squared. 5 times 1 is plus 5. Now I'm going to subtract off, and I'm just going to put my blue blocks there again. I'm going to distribute inside of here. 2x times 5x would be a 10, sorry, let me go back to black, a 10x squared, and 2x times negative 2 would give us our minus 4x. All of this is over x squared plus 1, quantity squared. Again, I will never distribute that out. So what's the point here is here's where we have to distribute the negative. And it's so important that you remember to distribute this negative to both of those terms. And a lot of people would say it would be minus 10x squared minus 4x, and it's not. So really what we're getting is y prime equals, we'd have 5x squared plus 5. Then we have to distribute the negative, so we'd have a minus 10x squared. Then we'd have a minus negative 4x, which would be a plus 4x, is what it turns into being. All of this is over x squared plus 1, quantity squared. Now we just combine like terms, see if there's anything else we could do. 5x squared minus 10x squared would be a minus 5x squared. Then we have a plus 4x, a plus 5. All of this is over x squared plus 1, quantity squared. Notice nothing factors out of the numerator. The numerator might factor, and I don't think this one does, but I certainly know x squared plus 1 is not a factor of the numerator, so I'm not going to be able to simplify this, right? So if there was a 5 in common on top and a 5 in common on bottom, I'd have to separate them out, factor them out, and then simplify them. But there's nothing in common, so that is our final answer right there. Sorry, let me underline that, and let me be sure to write that answer in the answer blank. So I have minus 5x squared plus 4x plus 5 all over x squared plus 1, quantity squared. Okay, so let's remember finding the equation for the tangent line. You need to find the point, which is simply plug the x value into the original function if y is not given. You need to find the slope, which involves find the derivative and then plug in the value into the derivative. And then you use y minus y1 equals m times x minus x1, point slope form. using the point and slope you just found, and then you solve for y. So again, remember this is going to be on the test. I told you this is going to be on almost all of your dang tests. Finding the equation of the tangent line is very important because that's all a derivative is. A derivative is the slope of the tangent line. So we're just going a little further, finding the equation of that tangent line. All right, example 5. This one looks really ugly. We'll work together to figure this out. Hopefully you did the review module, which will help you get through some of this problem with me. So it says, find the equation of the tangent line of f of x equals 3 minus 1 over x all over x plus 5 at the point negative 1, 1. So the first thing, awesome, already done. We know the point. The second thing we need to do is find the slope, which means we need to find f prime of negative 1. We need to find the derivative and evaluate it at that given x value. Well, here I'm going to say f of x equals, and I need to do some work on this because this is just a dang mess here. This is what was called a compound fraction, where we have a fraction over a fraction, and it's just a mess, okay? Fractions in the numerator or denominator of a fraction. So the easiest trick was, depending on the problem, but one of the tricks was multiply every single term by that denominator. Well, the only denominator here that I see, the only fraction that I see is x. So what am I going to do? I'm going to multiply every single term times x. Okay, let's see what happens. X times 3 would be 3x. In the second term, you'd have x times x, which is going to simplify just to a 1, right? So in the numerator, I have 3x minus 1. Now let's look in the denominator. In the denominator, I have x times x, which is x squared, plus 5 times x, which is 5x. So my real function is, in a cleaner version of it, 3x minus 1 all over x squared plus 5x. Again, I have my low function here, x squared plus 5x. I have my high function here, 3x minus 1. So to find the derivative, f prime of x, let me get to black, f prime of x, I need to use the quotient rule, which is low d high minus high d low over what's below squared. Well, let's do our work here, right? What's our low function? Our low function is x squared plus 5x. We need the derivative of the low function. The derivative of x squared is 2x to the 1, or 2x. The derivative of 5x is 5 times 1, which is just 5. So the derivative of x squared plus 5x is 2x plus 5. The high function here was 3x minus 1. We need to find the derivative of the high function. The derivative of the 3x is 3 times 1, or just 3, and the derivative of negative 1 is 0. So the derivative of 3x minus 1 simplifies to the number 3. Again, we're going to do low d high minus high d low over what's below squared. So let's plug it in. The low function was x squared plus 5x. The derivative of the low function was 3, minus the high function, which is 3x minus 1, times the derivative of the low function, which was 2x plus 5. All of that goes over the low function, which was x squared plus 5x, quantity squared. Again, never distribute out that denominator. Let's go ahead and multiply out that numerator. I'm going to distribute the 3 times x squared and the 3 times 5x. When I do that, I would end up with 3 times x squared is 3x squared, 3 times 5x is 15x. I'm going to go ahead and do minus. Now I'm going to use brackets here because I want to distribute the negative properly. Let's start doing this. I'm going to have 3x times 2x, which would be, I'm foiling it, which would be 6x squared. 3x times 5 would be plus 15x. Negative 1 times 2x would be minus 2x. And then negative 1 times 5 would be a minus 5. All of this is over x squared plus 5x, quantity squared. Well, let's look inside those parentheses. We could do that 15x minus that 2x, so that's going to give us 13x, right? And then on the next step, what I'm going to do is I'm going to distribute my negative to all 3 of those terms. Let's be very careful here. Again, we are not doing calculus, we're purely doing algebra. So what's left on top? I have 3x squared plus 15x. I would distribute my negative to the first term, get minus 6x squared. Then I distribute it to the next term, so it would be minus 13x distribute it to the next term, it would actually be a positive 5 because you're subtracting off a negative. In the denominator, I have x squared plus 5x quantity squared. One last step of simplification here to clean it up, just combining like terms in the numerator. 3x squared minus 6x squared is a negative 3x squared. 15x minus 13x would be plus 2x. Then we have our plus 5. And in the denominator, we have x squared plus 5x quantity squared. Lots of algebra. The derivative, if you look at the derivative, the only actual calculus we did was over here, finding the derivative of x squared plus 5x and finding the derivative of 3x minus 1. The rest of it was literally just plug it into a formula and algebra, algebra, algebra. So we're done with the problem, right? No, absolutely not. The whole point of the problem was to find the equation of the tangent line. All we have done is found the derivative, which is the slope at a given point. Well, we need to be more specific. We need this at x equals negative 1. So we need to find f prime of negative 1, which would be negative 3 times negative 1 squared plus 2 times negative 1 plus 5 all over negative 1 squared plus 5 times negative 1 quantity squared. So go ahead and plug that into your value right now and let's see what you get. I'm getting that the derivative is actually equal to 0. So that's weird to me, but that's fine. That's what I'm getting. So in the numerator, I got 0 because I have a minus 3, so minus 2, which would be minus 5 plus 5. So it is 0. So my slope is 0. So that's my second part, right? Was find the slope. The first part is find the point. The second part's find the slope. So the third part is do y minus y1 equals m times x minus x1. So let's plug it into this formula. This would be y minus my first y value, so that's y minus 1 equals m, which is 0, times x minus x1, which in this case would be x plus 1. Well, 0 times anything is 0, so this would just be y minus 1 equals 0, add 1 to both sides, and I'm getting y equals 1. So what's the equation of my tangent line is y equals 1. That means it's actually a horizontal tangent line. So what I encourage you to do is look at figure 3.23 in the textbook, which actually has the graph of this function. And when you look at the graph of this function, let me just roughly sketch it for you, okay? This is not meant to be anything too special whatsoever. But what you end up having is you have a couple vertical asymptotes on this graph. And the graph looks something like this right here. This is a rough graph. But at this point, this is the point negative 1, 1. The tangent line is actually y equals 1. It's a horizontal tangent line. So that's what we were able to just figure out. The equation of the tangent line of the graph at the point negative 1, 1 is y equals 1.